Gary Tyne he's the director of Pro-Reliability Solutions Ltd for Ireland and the UK, and he has worked, excuse me, for many years in the field of maintenance and reliability. He has experience of working in New Zealand, Australia, Papua New Guinea, the Middle East, USA, the UK, and Europe. And as you can see from there, he's pretty much worked in the four corners of the world. He has lots of experience in asset management and maintenance and reliability. And some of the areas that he has worked in the past include root cause analysis, RCM, FAMICA, asset strategy optimization, benchmarking, Monte Carlo simulation, and he also does a lot of coaching and training in reliability. He's the author and co-author of several reliability focused papers as well, so very much an expert. And tonight, Gary is going to talk to us about how to optimize maintenance strategies. Okay, so with that, I'll introduce you to Gary, and well done and good luck. Thank you.
Excellent, Jim. Thank you very much. Good evening, everybody, and thanks for registering to listen to this event. Got quite a few slides to go through, but you will all get a copy of the slides after the event. So for anybody who's trying to write notes down, you will get a copy, so nothing to worry about there. So yeah, the company was founded in 2018. As Jim mentioned, we're doing training, coaching, consulting, and we work across a diverse number of industry types. Some of the verticals: pharmaceutical, food and beverage, mining, chemicals, oil and gas, etc. And we've got offices we've just opened a recent office in Australia. We're in Dubai, Ireland, and UK. So we are over there in Ireland, and we've got feet on the ground, and the office is down in Wexford. So the first question I normally ask when I meet a customer is asking the question, what is reliability? And that often raises a number of different responses. But what we're generally looking at is, we call it the reliability viaduct, and it's made up of a number of different pillars, and reliability is really strengthened by these pillars. So we look at the reliability in the design, we talk about purchasing, installation of assets, the storage of assets and spares, how we operate and how we maintain, and then of course at the end we need to make sure that we're doing some effective planning and scheduling. If any of those pillars supporting reliability aren't being performed to the right level of detail and right level of excellence, then reliability will start to suffer. And you can see across the bottom there is a pillar the foundations called organisational culture. And really what we've recognised over the years is that we do need to have the right culture in place, or be working towards having the right culture to be able to support the reliability journey. Reliability, the case study that I'm talking about later on in this slide deck came out underneath the operate and maintain. And normally when we get called in, we're asked to go and do FAMICA studies, reliability studies, and it's usually when the assets are running. But we also get involved in the design phase as well. So reliability in design, some companies call it design for reliability, is an important element when installing new assets. But there is a definition for reliability, and it is the capacity of an equipment or a system to operate without interruption for a desired period of time under a given set of conditions. So that is the definition, but what we try to do is represent it as a viaduct to give people an understanding that we need to have these things in place to support reliability. So why do we need it? I mean, in a 12-month period with 8,760 hours to maximise our plant availability. And what we're looking at in asset management and trying to focus on the reliability of the assets is really digging into this, what we call the hidden profit. And we're trying to maximise availability by minimising the risk of failure. Are we doing maintenance that shouldn't be being performed? Are we doing shutdowns that are being extended unnecessarily? Are we having production quality issues? And what we're trying to do is really dig into that, what we call the hidden profit, to optimise the cost and the risk as well. and manage the risk associated to the asset. Where does unreliability come from? And this comes from a benchmarking study from a number of years ago. And quite often when we're working with customers, is reliability is seen as a maintenance activity. But what we're trying to do is understand that, well, really some of the issues that we're suffering may actually be inherent within the asset itself. And also, how are we operating the assets? Are we operating them within their design envelope? Or are we trying to get a few more thousand widgets per hour out of the machine when it wasn't actually designed to do that? And so you can see the ratios of unreliability there. So if we only focused on the maintenance section, then we are still going to see some unreliability from the production line. So it's just understanding that reliability is not just a maintenance activity. So what is an asset? I mean, people look at assets. It can be a piece of equipment. It can be a copyright. It can be land. It can be buildings, and it really is a thing or an entity that has value. And that description comes from ISO 55000, which is an asset management standard. And really, it is understanding what an asset is before we start to do the asset strategy optimization. Generally, we're focusing on the equipment, the production lines, and the machinery within inside a company. So what is the optimization? It really is about balancing the cost against the risk. And looking at the overall asset, the production line, it might be a single piece of equipment, it might be the full factory, and doing a risk analysis and balancing that cost. And as we get to the case study, you'll see how that eventually comes out. But again, from ISO 55000, asset management is referred to as the coordinated activity of an organisation to realise value from assets. And that's what we're doing with asset strategy optimization, is really getting the value from the assets and balancing the cost against the risk. So the goals of the programme are really, I mean, there's a number of them that we tend to look at. We certainly need to focus on the safe operation. We need to improve plant reliability and efficiency. This programme, the Asset Strategy Optimisation Programme, will provide a document base for planned maintenance, and also look at the resources that we're going to need and what spares do we need to deliver the strategy. So a number of elements come out of the start of a project, but some customers may have other requirements as well, but generally those are the key ones that we're focusing on. As we start to look at the assets, one of the starting points is really to understand how are the assets failing and where do they fail within their life cycle. A traditional view of maintenance is that we install a piece of equipment at day zero and it runs for a period of time, and at some point in the future it does start to wear out. And providing we do maintenance before it reaches the wear out phase, that we should get the maximum life out of the asset. And unfortunately, not all items do reach the wear out zone, and we do often suffer from infant mortality or early life failures. So being able to understand how a component is failing that's within inside an asset helps us optimise the overall strategy. And if anybody's heard of the bathtub curve and Weibull analysis, this is what I'm referring to here. There are actually 6 zones of the bathtub, and what's important for ourselves as we're doing the analysis is we look at the failure history, we do the analysis, and we're able to actually, and I'll be showing it in a moment, perform Monte Carlo simulation and actually predict what we're likely to see in the future based on past events, and understand how the components are failing within this bathtub curve. And it really is the attention to detail that's needed. We need to get down to the assets. We need to understand the failure modes and how they are failing. Some of the failure modes will suffer from infant mortality. Some of them will be random failures. Some of them will be wear outs. The job that I look at as the reliability engineer is to be able to get down to that level of detail, get to the failure modes, and put in place the optimum strategy to prevent or to detect a problem occurring. And that's the maintenance strategy. We're either trying to prevent the failure or we're trying to detect the failure before it happens. There may be some failures that are left as run to failure or no scheduled maintenance, but for me that decision is only made as part of the asset strategy optimization approach. And then ultimately we need to then design the maintenance task and align that maintenance task to the failure mode that we are expecting to see or we've already seen in our history files. So it really is attention to detail, getting down to the failure modes and understanding how those failure modes fail in terms of the life cycle and the bathtub curve. If anybody's followed reliability-centered maintenance in the past, RCM, there are a number of different RCM standards. This JA1011 defines the process, and there are 7 questions. And if we follow these 7 questions in sequence, then we should be able to determine if a suitable task or a suitable maintenance task can actually be applied. So this is going through looking at the functions of the asset, the functional failures, what are the failure modes, what are the effects upon failure and the consequences, and then what mitigating activities or mitigation tasks can be implemented and how frequent should we implement those tasks. So those 7 questions under the RCM banner help us drive our assets towards a point of optimization. What is a failure? Any unplanned interruption to the operating equipment or systems in delivering the desired performance is a failure. And what reliability methods are actually aiming to do is forecast those failures through understanding the likelihood of occurrence over a period of time. So that's, as we get down to the asset, down to the failure mode level, we're really trying to understand how often are we likely to see this failure mode occur over a set period of time, and ultimately what mitigating activities are we going to put in place to prevent those failure modes from occurring. So it's a question that we understand with customers is understanding how does reliability impact your business, and these are generally the responses that we get. We can look at higher maintenance costs. We can look at lower plant availability. We can see an increase in reactive or breakdown maintenance, and that is often related as well to an increase in safety incidents. We can look at the quality non-conformances and an increase in capital spend. So those are often the 6 common answers that we get when we ask that question, how does reliability impact your business? And so this asset strategy optimization approach, by taking a structured approach, what we are looking to do is actually flip these on the head and really get hold of the strategy and the costs and the risks associated to any potential failures. So one of the steps that we look at with customers is, have we done a criticality analysis? Where are we going to focus our effort? And criticality analysis is really about understanding where are the most critical down to the least critical assets within the business. Some of you may have already done this. We have customers who've got well-documented criticality analysis programs in place. We have others that have not yet done it. And so it's something that we try to help guide the customer, because what we don't want to do, we don't want to be putting all of our effort into some of the assets that aren't having an impact on the business in terms of the cost and the risk. So let's focus on the things that are going to hurt us the most, and define a program for applying the asset strategy optimization. So some of the things that the criticality analysis often cover is the customer impact, the safety, risk, impact on production. Have we got any single points of failure within the production line? What's the history telling us on this particular asset? Do we carry spare parts? And we look at probability of failures. But it helps us understand the asset structure and where are the critical elements within our business. Excuse me. So having that critical list, the output is often an ABC type ranking, or it could be a 1 to 5 ranking. There may also be safety critical elements, or in some companies we look at critical control points, where the maintenance is really non-negotiable. It might even be mandatory activities that we have to perform, and they will just come out at the top of the tree anyway through the criticality analysis. And once those criticalities have been identified, then we look to ensure that those criticalities are assigned against the asset within the CMMS system. There's a simple ranking there of an ABC, and in each category you can look at impact on production, plant reliability, maintainability, safety, quality and business impact, and we can take those criteria and do a simple analysis and look at, again, as I said, this was a simple approach, looking at the A, B's and C's, and then making sure that we'll then focus a little bit more detail on the criticality A's. Now, sometimes these categories you can see on this sheet on column E and column F, the safety, environmental and quality have been grouped, and the production, maintenance and reliability have been grouped. This was a fast track criticality analysis. Some of them will be a bit more detailed, where you split those into separate columns and you'll actually put numbering systems in place. And you may even come up with what's known as an RPN, a risk priority number. But this is just one approach to get your criticality analysis completed. When we do it in this approach, generally what we find is the ABCs, we generally find a split of 20% A's, 40% B's, 40% C's. It's usually that kind of ratio, but again, that varies on the production line, and if you've got duty standby redundancy built in, that can also influence that number. But generally, it's around a 20-40-40 split. What do we do then with that criticality? I've already mentioned we can put the numbers in the CMMS system, and that can also help them with the prioritisation of your work orders within planning and scheduling. Some companies use something called a RIME index, where the criticality number is taken into account and helps planning. It can help with your budgeting discussions. It can also help you understand where do we need to put our reliability and maintenance efforts. And then the next thing down at the bottom there, it talks about which assets are we going to do the asset strategy optimization on and focus the FAMICA effort. And that's really where that criticality analysis is leading to now. So we're moving from the high-level asset criticality down to what we call the FAMICA, which is a failure modes, effects and criticality analysis. And what we're now going to do is drill down to the asset, identify the failure modes, understand the effects upon failure, and then what can we put in place to mitigate those particular failures. So we're moving down into the FAMICA. And what we're looking to do is identify any critical or unacceptable conditions. I've already mentioned the failure modes that we need to look for, any fault detection capability, the effects and the mitigating actions. That's why we're actually performing this particular FAMICA. There are different types of FAMICAs that exist. I'm referring to the maintenance FAMICA process here, but there are process FAMICAs, there are design FAMICAs, slightly different variations, but what I'm referring to here is this maintenance FAMICA. So 9 key steps. What system are we going to FAMICA, which may have already come from the criticality analysis. Then we have to build the hierarchy, understand what are the assets. Then we go through that functions, functional failures, failure modes and failure effects, understanding what is the impact on the business. Then what we can do is look at the criticality at the lower level. So the criticality analysis previously was at the equipment level. We're now dropping down to the failure mode level and looking at which failure modes are having the biggest impact in terms of cost and risk. And it's those failure modes that we need to be able to mitigate against, hopefully through maintenance, but not always necessarily maintenance. It may be a redesign requirement on the assets that's needed. And then we can, if we need to, go back and look at, right, now we've applied these mitigations, have we been able to lower the risk? And that's what I'll show you as we move into the case study. One benefit that we do have is the asset strategy for MECA libraries. So do we need to start from scratch every time we build a FAMECA? We can have access to generic libraries. So we've got a number of libraries available to us with quite a number of different asset types from industry, with failure modes and documented maintenance tasks. That can be used as a first pass entry to building a FAMECA to help speed up the FAMECA process. Because it can be time consuming, but we are really, we've got 1 foot on the ground and we're starting to run when we're basing ourselves on the FAMECA library. But we do have customers as well that build their own libraries. I'm just currently working with a customer in the UK. They've got a number of food and beverage sites and they're looking to standardise their maintenance programme. And what they are doing is building a library that is personal to them, and they'll keep that on their own system, and everybody will be compared against that strategy library. So but we all know generic strategies. Some people call it maintenance templating. A centrifugal pump is a centrifugal pump, except when it's not, and we always still have to take into account the operating context. And some of the failure rates, some of the failure modes may not be applicable, some of the tasks may not be, but it is a starting point and it gets us on the journey. So moving towards the case study, so as we've worked through the presentation, just that introduction to reliability and the asset management, and now we talk about asset strategy optimization, working in towards the criticality, and then working towards the FAMECAs. And this is really how this case study came about. So this was some of you may know what this product, this piece of equipment in, it's known as a noosh filter, a solids liquid separation filter. And this was actually a study that I facilitated over in Switzerland a few years ago. And the objective for this study was to develop an optimised maintenance strategy at low cost and minimum business risk, and also identify budget and performance predictions. So we started, we knew this was the asset, we knew this was the critical piece of equipment, and we then went through the process. So we built an asset reliability model, and we used some reliability modelling software. I'll mention the name in a moment, but we built the reliability model. We then built the FAMECA within that model against the asset. Step 3, we validate the data inputs, and that's the effects, the consequences, proposed maintenance tasks, and even current maintenance tasks as well. Then we run a simulation of all the failure modes. So we run a Monte Carlo simulation, and then we identify where are the risks, high costs, and then that's where we focus on the optimization. And then that's where we're able to then develop new maintenance job plans for uploading to the CMMS system. This site had SAP. So we go through that process. So that's step 1. This is the hierarchy over on the left of the assets. It replicates the hierarchy that was in SAP. You'll see that that's actually, some of that is in French. Then what we did down at the asset level is we then start to do the functions, the functional failures, the failure modes. And at the failure mode level, that's where we start then with step 3. And we're working through validating the data. And you can see the tabs, you might be able to see the tabs on that step 3, where the effects, the failure rates, the maintenance activities. We can also take into account any alarms that may be early warning alarms for the onset of issues or failures. There's a commissioning tab, a redesign. So if we identify failure modes that are giving us high consequence or high impact, and maintenance can't actually mitigate against that activity or that failure mode, then we might have to do some redesign. So not only can we capture like the mechanical and the electrical type failures, we can also look at operational type stoppages as well. So I know in food and beverage, we do often come across what we call the high frequency, short duration stoppages, and we can model those as well. And those are the things that we really need to focus on to maximise the availability of the asset. So you can just see that logo down in the bottom. This package that we use at PRS is called Isograph's Availability Workbench. I first started using that back in 2001 when I was a reliability engineer with Shell in New Zealand. So the Isograph software, they're headquartered out of the UK, but it is a nice neat package that we use to help optimise the asset strategies. So that's the first three steps. Step 4, once the model's complete, then we want to run the Monte Carlo simulator. And again, this ran over a period of 10 years. A Monte Carlo simulator is a random number generator built inside the software. And what that then allows us to do is look at where are the high impact problems. And we can look at those issues from an operational and a quality perspective. We can look at it from safety and environment, and then we can look at the cost as well. So we can look at the high cost failure modes. And what we need to do is compare that with current practice as well. So, and I'll show you a results slide in a moment. So again, not wanting to reinvent the wheel, when we're working on existing equipment that has already got a documented maintenance strategy, that's the starting point. Let's work with what we've currently got, use the failure history that we've got, and start to build the model. So once we've built current practice, we can validate that data with what we have been seeing, and then we look at the optimization of the current strategy. But by using these graphs, it can help us focus on the things that are hurting us the most. And that's what we're doing then. The software, the AWB actually has an algorithm, an optimization algorithm inside. And what that does, it allows us to look at cost curves. And this curve that you're looking at on the screen now, on the left-hand side of the curve, that's known as over-maintaining. And on the right-hand side of the curve, it's under-maintaining. So on the left-hand side, we're doing maintenance too frequently, and on the right-hand side, we're not doing it enough. And what it allows us to do is to actually identify the lowest cost and risk point within the optimization curve. And that then allows us to determine when should we be doing the strategy. Now, the software might make a recommendation, as this example here is showing a 4-weekly inspect every 672 hours. But it might be that your strategy on that part of the plant is 3 months. What you can do is you can then set it to 3 months and look at what is the impact. Are we likely to see an increase in failures? Is the cost going to increase? And so you can start playing the what if scenario. This example here is just showing one of the primary gearbox failure modes, where we compared run to failure with monthly vibration. Then we had monthly vibration checks with yearly oil analysis. And then we looked at the opportunity to having an online vibration sensor alarm. And we compared the life cycle costs over 10 years as to what that particular activity would deliver. We can also see the risk, the operational risk has decreased as we've changed the strategy, and also the amount of failure downtime has also decreased as well. So it allows you to, like I said, you can get the attention to detail, you can look at the things that are hurting you, and you can start to do a level of optimization to produce a new documented strategy. So that's step 5. The results on this particular study, so what we did is we started current practice, which is the second bar from the left. As you can see, current practice and run to failure are actually the same models. This particular filter was one of 3, so there was always the mindset that we had redundancy. And whilst we've got redundancy, we can just run one to failure, fix it, and then start up one of the other 2. And you know that might work for a while, but then when the others start to fail at the same time as the one that's running, and you soon start to lose plant availability. So the business recognised that we had to do some strategy optimisation. So we took the current maintenance and all of the failure history, and what we did is we optimised it, and they wanted to align it to an annual shutdown. So we compared running it, all of the offline maintenance, what would happen if we just did it every year, rather than having short-term interval stops, 3 monthly, 6 monthly. And we also looked at what would happen if we pushed out that yearly shutdown out to 2 years. What would be the financial impact in terms of production loss, which is the effects. So that effects bar that you can see, that's the production loss per hour. There's a cost per hour that sits under that, and that adds up to a total cost over the year. And then we were able to identify redesign within the model as well. So I do remember on this particular pressure filter, there was a single hydraulic power pack. And when that power pack failed, it actually stopped the filter for 24 hours. And so one of the redesigns was actually to put in a duty standby power pack. So when the power pack failed, we had a duty standby operation, and we'd start up the spare one, and the one that's failed could be removed and repaired, and production would continue. So that actually reduced the downtime production impact by having a duty standby operation. And there were a few other redesigns in there as well, but I remember that was a key one. And there was another one where it was actually software related, and the software was doing a simulation, and it was doing a simulation, I think it was every shift, and stopping the machine for a couple of minutes. It was like a high frequency, short duration stoppage, and that software program needed to be changed to remove that stoppage. So a few different redesigns came out, but what's good is you can actually model this in a reliability modelling environment, and look at the benefits before the strategy gets implemented. And interestingly, on there you can see the operational criticality. So that's the risk reduction. So we're able to reduce the risk to the business, and the scale on the right hand side is the risk number, and that would have been married up to the company's corporate risk matrix. The strategy, once the maintenance strategy had been optimised, what we were able to do is actually look at it from a reliability block diagram point of view. Some people might have heard of RAM studies or RBDs, reliability block diagrams. We were able to convert the FAMICA into a reliability block diagram and look at the overall impact on plant availability. And it's, as you build the RBD, you've converted the FAMICA, this starts to look at what's in parallel and what's in series, and where are my availability losses. So not only have you done your FAMICA and focused on the failure modes that are hurting you in your cost and risk point of view, but you can go one step further and then look at it from an availability. And you can also look at it from a capacity point of view. This one was just pure availability. We could have run capacity throughput on here as well. So if we wanted that 10,000 widgets an hour, what will this strategy deliver us? RAM modelling, RBDs, it's another subject on its own, but I just wanted to add that in as a slide to show you the value in building your FAMICAs and also converting it to availability profiles as well. But that's not always a requirement for an asset strategy optimisation programme, but it's an added value if we decide to do that at the end. So converting it into an RBD is a value add. The outcome for this particular equipment, we identified 87 failure modes. 48 of the failure modes had new tasks attributed to them. 39 failure modes were left in the run to failure, or no scheduled maintenance. And out of the 48 maintenance tasks, 14 of those tasks were preventive, which were like fixed time replacement of components, and 34 tasks were predictive stroke inspection type activities. So that may have been some sort of condition monitoring or visual inspections. And once we've created those maintenance tasks, those were actually developed into 12 maintenance plans and uploaded into SAP. So to summarise the presentation, we've gone through and talked about the reliability and asset management. We've talked about what it is and why do we need it. What does asset strategy optimization deliver when we've got a structured process in place? The importance of understanding failure behaviour and how we understand where it fits on that bathtub curve. Are we suffering infant mortality? Are we having random events? Are they things that are wearing out? And the maintenance tasks then get aligned to the failure modes. And then understanding reliability and how it impacts the business. What are the things that actually can take place when we're not focusing on plant reliability? Talked about criticality analysis at the asset level. I talked about an ABC, or you can do 1, 2, 3, 4, 5, or you can have risk priority numbers. But having a structured criticality process in place, and then moving forward from that, we can drop down into the FAMICAs, and we can start looking at, the hierarchy and working through the failure modes, the functions, functional failures, failure modes, as I've just shown you there in the case study. And also having the benefit of using asset strategy libraries to kickstart the program. And also, if you needed to develop your own internal library, that also adds value as well within a business. And then we've just gone through that final case study from Switzerland. So hopefully everything I've discussed up to the case study, you'll see how that's all come together and delivered the results for that particular asset in Switzerland. So thank you very much. I think I'm okay with timing. But yeah, I'm happy to open up, Jim, if there's any questions from anybody. So thank you.
And Gary, thanks very much as well. Very informative set of slides there. A very nice and interesting case study at the end. Yeah, we have a few questions. I'm just going to kick one off. I mean, what I see is very much, are you dependent on the accuracy of the data that you're using at the very start? I mean, to what extent do you need to have reasonable data coming in to start the whole process, like CMMS data you talked about for 10
Sure.
years? Could you talk a little bit about that, and how do you handle the situation where your data isn't great?
Yeah, I would say probably 90% of the reliability models that we build, 90% of them we've had poor data. And quite often the data is not being collected at the right level within the hierarchy. And we're not actually down at the equipment level. I've actually seen failures being reported to the building, and so when you start to try to filter on particular failure modes and try to look at mean time between failures, it's not always possible. I think what happens in this approach, though, Jim, is as we build the model, what we are doing is sitting with a team. So we'll have a number of key users from the facility, and we validate the failure rates that we're applying to the failure modes. So how often do we see this occur? But the first thing we would do is do some data analysis, look at the quality of the data. We can create viable data sets within the software when we do have some failure modes, and we can look at the quality of the data by looking at what's called the epsilon. We look at the line of best fit, which will give us an indication of the quality of the data set. But where we've not got good data, it is really a facilitation exercise.
Yeah, and in the case study that you just showed us, what was the data like, or the data like that you started with?
It was quite poor.
Okay,
Yeah,
so
it was
what you were
quite poor.
depending on was having the group of people in the plant who knew the plant giving you some of that information about the failures and how often. So they were probably taking a lot of that from basically the top of their head from their own
Yeah,
experience.
it was. A lot of that was the case, and we documented that, but we also included the OEM. So we had
Okay.
one of the OEMs sat in on the study, and he was able to bring within, although he didn't, for obvious reasons, hand over the data for us to analyse.
You can be sure he didn't hand it over.
No, he was actually
Did
able
you
to
ever
give
hear of
some.
spare parts? The industry called spare parts?
That's right, exactly. So he was able to give us some very good indicative failure rates for certain component types.
Mm,
Yeah.
good. Okay. Is the software package that you use, is that proprietary, or is it something that you have?
No, anybody can purchase the Isographs Availability Workbench.
Okay.
It's available for any company to go and buy. Yeah,
Have
we use it.
you seen anybody link it to their CMMS?
Good question. I have seen it linked. I saw it linked in Australia with a mining company. So it has been done.
Okay.
I think there are, within the AWB software, there is a SAP portal and there's a Maximo portal that will link, and you can make the connections and you can bring data in live, do your wireable analysis, change your strategies and feed it back into the CMMS system. Some customers don't like having external software linked for security reasons. But yeah, if anybody wants a demonstration of that, we'd be happy to share that with anybody.
Okay, yeah, and that's a follow up for people if they want to afterwards to contact Gary. I mean, we always encourage people if they have further questions to do so, and he'll have all those contact details in the slide deck that'll be available afterwards. Okay, so some more questions here. One from John Coleman. He has a couple here, but I'm just going to go through the first one. Where does reliability and maintenance fit in the context of a more sustainable, climate-friendly world? Okay, and the second part of that question is how will that be affected by the circular economy that we're starting to see evolve?
Yeah, so definitely from a greener perspective, I mean, reliability and maintenance have a massive part to play. You know, when you think about, I mean, one of the big topics that we're working on with customers at the moment is electric motors and how we aren't probably looking after our electric motors as well as we should be, and that they are using more energy than that customers realise. So we're calling it green reliability as a topic. We're also looking at steam energy usage within your steam traps and your steam management system. So reliability of those components, the reliability of your steam traps, the reliability of your motors, all of that is definitely contributing to supporting a greener environment and a climate.
Okay, and a second question there for John was, in exercises like this, how can we be sure that we're focusing on the overall long-term strategy as opposed to just doing what you're doing for cost reduction purposes? How do we make sure that we don't become short-term in the exercise that you showed us?
Yeah, so the models that we're building is quite often we're building a 10-year plan.
Okay.
So the plans that are coming out of this are not just a 3-monthly, 6-monthly, 12-monthly activity. We are looking at life cycle, and we're looking to get to the point of disposal. So following the life cycle analysis is definitely an important element. So I mean, some models that we've run are 30-year strategies. So it is certainly about sustaining the long term with the strategy that you're building.
Okay. Question here from Tyler Helm. He says the reliability pillars mentioned are all equally important, but should the organizational culture be the first focus prior to working on the pillars? Have you ever been to an organization and recognized that the culture is not in the correct place to start with?
No, most definitely. I think, it shows the organizational culture as the foundations of those pillars, and it absolutely is. But if we were to wait for the cultures to be in the right place to deliver reliability, then we wouldn't be working in any of the pillars. And I think it's a recognition when you're on the reliability journey, you know, there will be pockets of excellence in some of those viaduct pillars, and, you know, work on those pockets of excellence, get the results, keep things moving, and also have a recognition that the culture needs focus as well. So you need to be moving them both at the same time. A lot of organisations I visit, you know, the culture is we'll run this to failure. We'll get as maximum number of hours out of it, let it fail, and then replace it. And there's no understanding of that cost and risk. And you know, that shop floor culture is breakdown maintenance, and often it's because nobody has seen it any different. We've always done it that way, yeah. And really what we're trying to do is break that approach.
And do you involve craftsmen and technicians in this exercise?
Oh, most definitely, and operators as well, Jim. Yep. So plant operators, technicians, we'd probably do a little bit of training. You know, and quickly what we often see is we'll see people who get it very quickly. There's a very quick understanding, and it's why have we not been doing this years ago? And others it'll take a little bit longer to understand. But you know, we're all moving in the same direction. Some may be moving faster than others.
Okay. Question here from John Byrne. What is the best way to do a spare parts criticality assessment to support reliability, to optimize spare parts spend and minimize risk?
No, fantastic question. So the way we approach that is where we've built the reliability models, we actually can use the software to help us do the spares optimization. We can either do that in the FAMICA, because at the FAMICA level, when we get down to the failure mode, we're assigning the resources, so we're assigning the labour, and we're assigning the spares required for that particular failure mode. At that point, we can run a simulation to look at the min-max holding levels of those particular spares. So you can do it at the FAMICA stage, or as I showed the reliability block diagram, the RAM model, what we can also do is do a spares optimization to look at what impact unavailability of spares will have on availability of the plant. So there's two approaches that we take, and it all really depends on what the customer's ultimate output is. What is the goal of the study to start with? But we have two approaches, optimizing in the FAMICA or optimizing in the RAM study.
Okay.
Yeah.
Very good. If you had to do, let's say, a spare parts criticality assessment just as a standalone exercise without, you know,
software.
I mean, say somebody had a pretty robust plant and it was fairly reliable and the availability was good, but they just felt that they had too many spare parts. What approach would you take just to focus purely on the spares as opposed to doing a full reliability analysis?
Okay. Yeah, good question. I would probably do, we have a little spares flow chart that looks at a number of criteria. You know, does it have an MTBF of less than 1 year? Is there built-in redundancy? What's the lead time of the spares if we don't have it? So it's almost like a simple criticality analysis, just looking on your spare parts. It's like a criticality analysis of your spares, and we would do that simple approach in an Excel spreadsheet.
Okay.
Yeah.
Question here from Shane Neal. He says, great presentation. What are the main challenges you see in pharmaceuticals compared to heavier industries like oil and gas and mining?
Okay, yeah, thank you, Shane. Good question as well. There are definitely differences. I think in the pharmaceutical world, and for obvious reasons, most definitely obvious reasons, is the quality, the quality teams, the quality assurance teams, the influence that they have on strategy approvals can often add to the time it takes to get the strategy optimized to actually being implemented, because there's quite a rigorous, and again, for the right reasons, but in the oil and gas world and maybe mining as well, you know, once you've done your strategy, it doesn't go anywhere else other than to the maintenance manager, and there's an approval, and into the system it goes. But I find working in the pharma industry that it does take longer. It does take longer to get the strategy finally approved and implemented. That's probably the biggest difference. Otherwise, everything else is more or less the same approach.
Okay. Yeah. Question here from Declan Finn. Have you ever constructed an overall reliability model for a plant to calculate the overall plant reliability? And if you did, what software would you use?
That's an excellent question. I like these questions are very good.
We're very smart in Meta Asset Management.
You are, Jim. You are. One of the first studies I did when I worked in Australia was actually on a nickel refinery. And what we did is we actually built a full site RAM model. So we built a RAM study inside the availability workbench, inside the isograph software. It had 4,000 blocks within there. And we did that at the asset level. We didn't go down to failure modes. And at the asset level, we had the mean time between failures, mean time to repairs, 4,000 blocks. The project took 58 days to complete for the whole facility with 4,000 blocks. And at the end of it, we were able to run the simulations to look at which assets were having the biggest impact on plant reliability or availability. And then we were able to work on those for a FAMICA. So yeah.
Was it a continuous plant, or it wasn't? It was a continuous process.
It was made up of there was seven plants on site, and that they did all feed into each other, and each individual plant was a continuous process. There was only one plant that was batch operated. There was one section that was batch, and everything else was continuous.
Okay, interesting. Yeah. Interesting. Okay.
Yeah,
that's basically it, Gary. They're all the questions that we have for you for this evening.
Thank you.
As I said, if there are any follow-ups or any further questions, you'll be able to get Gary's email and his contact details in the slide deck. So I'd encourage you to, send him an email and ask another question and start a conversation if you do have anything
absolutely
in the reliability subject matter that you need help with, then please contact Gary. Okay, so I'm going to draw a close to tonight's proceedings. I just want to thank Gary very much and Pro-Reliability Solutions for allowing him to come and talk tonight and tell us a little bit about what he does. Gary, thanks very much. It was very informative, kept everybody engaged as well, so well done.
Thank you.